Hello, students. Today we are going to start our new topic, that is metals and non-metals. Okay? It's totally not new to you. Actually, what are these metals and non-metals? These are the elements that are found in the atmosphere of Earth and in the Earth's crust as well. So what are elements? Element is any chemical substance that is composed of only one type of atoms. Only one type of atoms. Okay. For example, if we talk about metals, suppose we have a metal that is sodium. So when is sodium an element? When we have a sample and whole sample is composed of only sodium atoms. Okay, we have only sodium. Now, similarly in case of non-metals, suppose let us take this example of chlorine gas, Cl2 gas. Now, this chlorine gas, this is a molecule. It is formed when two chlorine atoms combine with each other. So again, only one type of atoms are present, that is atoms of chlorine. So this is also an element, and sodium is also an element. Okay, so this was all about elements. Now let us move towards their properties. Let us talk about their differences and similarities. They're both physical and chemical. Okay, now there are two types of properties. Okay, so we'll be discussing properties in two terms. Okay. First one is chemical properties, and second one is physical properties. Okay. Now, what are chemical properties? These are those properties which elements, metals, non-metals show while they react. Okay. So chemical properties are those properties which are shown by elements when they react with similar atoms or with different atoms. What are physical properties? These are those properties which are visible to us. Suppose hardness, okay, density, and so on. Refractive index. Okay, so we will be discussing both of these chemical and physical properties of both metals and non-metals. Okay, let us continue. So their first thing that we should know about metals and non-metals is how do we classify them? How can we tell which of the elements are metals and which of the elements are non-metals? Okay. Let me tell you that we have in our periodic table, we have this hydrogen, then helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then neon. Now, if we talk about their atomic numbers, atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, now let us go into their electronic configuration. You already know that in case of a neutral atom, when the atom is neutral, the number of electrons is equal to atomic number. Okay, so if we talk about the electrons that are present in these elements, in case of hydrogen it will be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now, if we write their electronic configuration, okay, what is electronic configuration? It is the arrangement of, it is the distribution of electrons in the shells of an atom. So, here it will be 1 in first shell, 1 electron in first shell. In case of helium, it will be 2 electrons in first shell. In case of lithium, 2 in 1, and then 1 in second shell. Similarly, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, and 2, 8. Now, I don't know whether you are well aware about this octet rule, that is the stable electronic configuration or not. Usually we say in terms of chemistry that if any atom has 8 electrons in its outermost shell, then it is considered as the stable electronic configuration. That means the element, the atom, is absolutely free to stay in monoatomic form. It doesn't require to react with any other element. Okay. So now if it is clear, here I can introduce you to another term, that is valency. Valency. What is valency? It is the combining capacity of an atom. Okay, it is the combining capacity of an atom. And how do we calculate valency? How do we calculate valency? Valency is calculated. It is calculated like this. If your valence shell is having 1, 2, or 3 electrons, then it will be equal to its valency. So here, in case of lithium, 1 electron in outermost shell, 2 electrons in outermost shell, boron, 3 electrons in outermost shell. So their valency will be equal to 1, 2, and 3 respectively. Now, if we have 4, 5, 6, and 7 electrons in the outermost shell, then our valency will be equal to 8 minus valence electrons. Okay, now, if we look into this, we have here 4 electrons in outermost shell, 5, 6, and 7. Now, what will be their valency? It will be, in this case, 8 minus 4, that is equal to 4. In case of this, 8 minus 5, that is equal to 3. In case of this, 8 minus 6, okay. Okay, here it will be 8 minus 6, that is equal to 2. And here it will be 8 minus 7, that is equal to 1. So now, here you can see that valency of carbon is 4, valency of nitrogen is 3, valency of oxygen is 2, and valency of oxygen is fluorine is 1. Now, here you can say that when the number of valence electrons in outermost shell, so when the valence electrons are 1, 2, and 3, any atom that has 1, 2, or 3 electrons in their outermost shell, they will be considered as metals. Okay, they will be considered as metals. So you can easily identify that lithium, beryllium, and boron, these are what? These are metals. Okay, and what in the case of this, if we have valence electrons 4, 5, 6, and 7, then we will be categorizing those elements in non-metals. Okay, I hope it is clear to you guys. Okay, so let me differentiate it. So the first, we will be drawing it as metals versus non-metals. Okay, metals versus non-metals. So our first difference will be metals have valence electrons is equal to 1, 2, and 3. And in case of non-metals, it is valence electrons are usually 4, 5, 6, and 7. Okay, we are done with the first difference, that is the definition of metals and non-metals. Okay, if we move towards the second difference between metals and non-metals. Okay, so the second difference will be on their physical state. Physical state. Metals are usually found in solid state. Okay, so metals are generally Metals are generally solids. And what is it in the case of non-metals? Non-metals are generally, non-metals are found in either solid, liquid, or gaseous state. Okay. Now we will be going into their examples. If we talk about sodium, magnesium, aluminium, these are all solids. But this is chemistry, and guys, exceptions are always there. So you will be writing exception. What is the exception? It is mercury. Mercury, it's gallium, and it is cesium. These three guys are found in liquid state. Liquid state at room temperature. Okay. So these are the exceptions. And now if we talk about non-metals, suppose we have chlorine, oxygen, nitrogen. These guys are found in these are found in gaseous state. Okay. Now if we talk about bromine, this is found in liquid state. And what about carbon, phosphorus? Okay, it is C, carbon, phosphorus. These are found in solid state. Okay, guys. So what is the reason behind this? I can further explain it to you. Why are metals generally found in solid state and non-metals are found in liquid gaseous states? So generally non-metals are found in gaseous state. So why is it so? If we talk about metals, let us take this example of sodium. Sodium, its atomic number is 11 and its electronic configuration will be 2, 8 and 1. Okay, now look into its electronic configuration. This sodium tries to become stable, and to become stable it has to lose this one electron, so that its outer electronic configuration follows the octet rule. So it will be losing one electron minus electron. It will be becoming Na positive, and this electronic configuration will be 2, 8. Now look, this one electron is always present there. If we have a crystal of sodium, how does it exist? Suppose it's like this. We have sodium plus, we have sodium plus, we have sodium plus, here sodium plus, here sodium plus, here sodium plus. Now these electrons, these valence electrons that we talked about, in order to get stability, these electrons are found here. These are loitering here. Okay. And these electrons form a sea of free electrons. And what are the consequences? You are genius enough to understand it. That what are the consequences? You know that positive charge attracts negative charge, unlike charge attract each other, and due to what forces? Due to electrostatic forces of attraction. Electrostatic forces of attraction. Now, what will happen here? We have lots of positively charged ions and we have a sea of electrons. So there will be a lot of attraction between these opposite charges. Okay. So that's why they tend to remain very close to each other, and hence we get a solid state. Now, it's clear about metals. Now, what is it that happens in case of non-metals? Now guys, you need to be very sure about this. Now, let us talk about oxygen. Oxygen. How does it exist? Actually, oxygen is here. It has Okay, let us go into the detail. Let us go into the detail. What is its atomic number? Its atomic number is 8. Oxygen atomic number 8. So its electronic configuration will be 2 and 6. So it has 6 electrons in its outermost shell. Let us draw its Lewis. Let us draw its Lewis dot structure. So it has 6 electrons in its outermost shell, and we have here another oxygen atom. It's also having 6 electrons in its outermost shell. Now, to complete the octet, they will be forming a double bond between each other. So we will be getting this O2 molecule. O2 molecule. Now, this bond is a very strong bond, and oxygen is very electronegative. So it is never letting these lone pair of electrons to go away from its nucleus. Now, these electrons are localized. They are intact with these oxygen atoms. So there is no chance that these electrons will be leaving this oxygen atom. Now, what will happen? Look. Now, the case is here, what happens here, that similarly, an other oxygen atom, oxygen molecule will be there, and here there will be another oxygen molecule. Now, every oxygen molecule is having these lone pair of electrons. Here it is also having lone pair of electrons. Here it is also having lone pair of electrons. And what are the consequences? You know that these lone pair are negatively charged, these electrons are negatively charged, these are negatively charged, these are negatively charged. And what is the effect between negatively charged? When they come close to each other, they repel each other. This will be going towards this way, this will be going towards this way. Okay, they hate each other and they go away from each other. That's why non-metals generally are found in gaseous form. Okay, I hope it's clear to you guys now. Okay, so why do non-metals exist in gaseous form? This is the reason. Let us take another example. If we talk about nitrogen, N2. Okay, what is the atomic number of nitrogen? 7. Electronic configuration 2, 5. Now, here this is nitrogen atom, here another nitrogen atom, 5 electrons in outermost shell, 5 electrons in outermost shell. Now, to complete their octet, they will be making nitrogen-nitrogen triple bond. Okay, so here is the molecule N, triple bond N. What? Lone pair of electrons. Another molecule here, nitrogen-nitrogen, lone pair of electrons. Another molecule here, nitrogen, triple bond nitrogen, negative-negative. So, again, what is the case here? These are negatively charged, 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 these are negatively charged. And again, like charges will repel each other. Like charges will repel each other. Okay? So, when they repel each other, the distance between two molecules is very large enough. And you know that when the distance between the molecules is very large enough, that is the forces of attraction between the molecules is very less. So they stay away from each other, and what is the result? The result is gaseous form. Okay, I hope it is clear. So I guess this is enough for today. So we will be meeting in our next session. This session was absolutely an amazing session. So meet you guys in next amazing session. Till then, bye, take care.